Welcome back to the podcast. Today, we're diving into a fascinating topic at the intersection of technology and manufacturing, inverse rendering, and how it's revolutionizing tomographic volumetric additive manufacturing. This topic is captured beautifully in a recent paper titled Inverse Rendering for Tomographic Volumetric Additive Manufacturing, authored by Baptiste Nicolet and his team. So, what exactly is drtvam? You might want to think of it as a powerful framework that allows for the optimization of patterns in additive manufacturing. Imagine you're trying to create intricate 3D shapes, but you want to ensure that every layer is just right, allowing for complex designs that traditional methods struggle with. That's where drtvam comes into play. Now, one of the standout features of drtvam is its use of physically based differentiable rendering. This might sound technical, but in simple terms, it helps produce incredibly realistic patterns by simulating how light interacts with different materials. So if you're working with scattering printing media, think of materials that can spread light in unique ways. You'd be able to design far more effective and intricate structures. But it doesn't stop there. drtvam supports arbitrary vial shapes and projector motions. This flexibility means you're not just limited to standard objects. The system can adapt to whatever unique challenges you throw at it. It's like having a highly customizable tool set that empowers creators, or should I say manufacturers, to think outside the box. Now let's talk about installation. For those of you interested in getting your hands on this tool, installing drtvam is straightforward. All you need is Python, and you can use a simple command line input. How cool is it that such sophisticated technology is accessible to anyone willing to try it? And if you're looking to dive deeper, there are plenty of resources available, including documentation and even Jupyter notebooks. Great for those who love a hands-on approach to learning and experimentation. So here's a thought. If this technology can help us push the bounds of what's possible in manufacturing, where do we see it going in the next few years? Could we be looking at custom-designed prosthetics or even unique art pieces produced on demand right in our own homes? As we wrap up this discussion, it's clear that drtvam represents a leap forward in additive manufacturing. From its intricate optimizations to its applicability in various media and designs, it opens doors to creativity and innovation. Whether you're a seasoned pro in manufacturing or just someone interested in tech, there's no doubt that advancements like drtvam will shape our future in exciting ways. Thanks for tuning in today. If you're curious about the project or want to learn more, be sure to check the show notes for links to the paper, the documentation, and even a teaser video. Until next time, keep exploring and questioning what the future of technology holds.